Multiplying and dividing rational functions. When we multiply rational functions, no different than multiplying fractions. But a couple of things I want to make a point of first. This is where factoring, which we used in the first week, as well as understanding how exponents work, really pay off in doing quick and correct analyses. Notably, I always make the joke that mathematicians are lazy, but the truth is, the simpler we can make something through simplification or remodification, the less likely we're going to make a mistake. And that's some of the things I want to show you. I want to go over some of our exponent rules first, which I'm sure you probably already know. When we're adding exponents, multiplying exponents, we have the same base. We add the exponents. X squared times x to the fifth is x to the seventh. 2 plus 5 is 7. And this works because if I had 2 squared times 2 to the third, that should, based on this, equal 2 to the fifth. Well, 2 squared is 4. 2 to the third is 8. 2 times 2 times 2 is 8. And then 2 to the fifth is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. And 4 times 8 is 32. So this is why we do this. Another area, let me erase this here, I want to talk about is looking at when we multiply exponents together. We multiply the whole numbers together. 2 times 6 is 12, and we already know this. There's my x squared times x, and that's the same as x to the first, which is x to the third. And then y to the third times y to the ninth is y to the 12th. No different what we did in the previous example. Also, remember, if we have a rational expression, y to the third over y to the eighth, that's the same as y to the third over y to the negative 8. Anytime we have a positive exponent in the denominator, that becomes a negative when we eliminate the fraction. And we subtract. 3 minus 8 is negative 5. And also simplification, let's look at this right here. I wasn't drawing that line. When I'm simplifying here in this next expression, 9x squared over 3x to the fifth. Well, 9 over 3 is simply 3. X squared x to the fifth, that's x 2 minus 5, which I got right here, which is at 3x to the negative 3. More importantly, I like canceling things out. And this is where we can make life a lot easier. I have 6x to the fifth over 5 times 2 over x, 3 to the x. And let's rewrite this. Step 1 is I have 6x to the fifth times 2. Well, my numbers are 6 times 2. Got x to the fifth here. Well, that's 12x to the fifth. And then 5 times 3 is 15, which comes right here. And there's a single x there. So it's 12x to the fifth over 15. 12 over 15 is 4 over 5. And then x to the fifth over x, same as x to the fifth times x to the negative 1 is x to the fourth. And looking at the original equation, the only thing x cannot be is 0, because 3 times 0 is 0. And that would put a 0 in my denominator. Now, multiplying rational expressions with polynomials in both numerator and denominator, this is where we talk about simplification. Here's my equation here, or two sets of equations, I'm sorry. X squared minus 9 over x squared minus 10x plus 15 times 4x minus 2 over x squared plus 5x plus 6. What I want to do is I want to factor these out, and you'll see why in a minute. My first expression, x squared minus 9 over x squared minus 10x plus 25. Well, this is a difference of squares right here. So this is x plus 3 and x minus 3. I'm just going to leave it like that. And if I use the PQ method to factor this out, this is x minus 5 times x minus 5 is actually x minus 5 squared. My second equation right here, for x minus 20 over x squared plus 5x plus 6, I can factor out that 4 right there. And then use the PQ method. X squared plus 5x plus 6 is simply factored x plus 3 over x plus 2. And here's my two equations, again, expressions factored out. And I'm going to start canceling things out. I've got a x plus 3 here, x plus 3 here, which I've represented right here. And right here, there's also x minus 5 in the numerator and the denominator. So what I'm left with is 4 over x minus 3 over x plus minus 5 over x plus 2. Now, I look at this, I know x cannot be 5, because 5 minus 5 right here would be 0. And x cannot be negative 2. But I also have negative 3, because in the original equation, as I factored this out, right here, I could not have negative 3, because in the original equation, negative 3 plus 3 would be 0, and that would also cause a problem. And that's where we have my asymptotes right here in this graph. And actually, we'd have a point asymptote, or basically a hole, and where x equals minus 3, which would be 2, it'd be right here. A little hole right there. Here's another example. Negative 4x minus 32 over x squared minus 12x plus 36 times x squared minus 9x plus 18 over 3x is 24. It's going to factor these out again. My first expression, 4x minus 32 over x squared plus minus 12x is 36. Well, I can pull a negative 4 out of here, and that leaves x plus 8. In the denominator, this is perfect square trinomial, x minus 6 times x minus 6. My second expression, x squared minus 9x is 18 over 3x is 24. This is, if I use the PQ method right here, this simply is x minus 6 times x minus 3. And in the denominator here, I can pull a 3 out. That leaves 3 times x plus 8. I'm going to put it all together here. And what I have here before I even start multiplying things out, I can cancel out x minus 8 in the numerator, x minus 8 in the denominator. There's x minus 6 numerator and denominator. I'm left with negative 4 over x minus 3 over 3 times x minus 6. And there's nothing I can really do here. Now, obviously, my x cannot be 6. But when I look at my original equation, I also said it can't be negative 8. And why is that? Because in this expression, 3x over 24 in the denominator, negative 8, if I put in x, 3 times negative 8 is minus 24 plus 24, would make it 0 in the denominator. We do not like that. Now, as we learned in middle school, keep, change, flip, I do the same thing with rational expressions. Again, less likely to make mistakes and it's easier to factor out. I've got y equals x squared minus 16 over x minus 2 divided by x squared plus 3x minus 4 over x minus 8. I'm just going to flip these around. I got to use the reciprocal, which now takes this x minus 8 in the denominator, x squared plus 3x minus 4 in the numerator, and we're multiplying. So let's see what I can do with this. Well, my first expression, x squared minus 16, right here over x minus 2, that numerator is a difference of squares, x plus 4, x minus 4. And my second expression is x minus 8 over x squared plus 3x minus 4. If I use the PQ method, that can factor out x plus 4, x minus 1. Let's put all these together. What I can't cancel out here is an x plus 4 in the numerator and an x plus 4 in the denominator. And I'm left with, and I really wouldn't multiply these out. This is actually simpler to use this way. Where can it not be 0? X minus 4 times x over x minus 8 over x minus 1 and x minus 2. Well, it can't be 2 here or 1, because that puts 0 in the denominator. Well, why can't it be 8 or negative 4? Because in the original expression, this right here 8 minus 8 would make it 0 in the denominator. Even if it's dividing it, it is a 0 in the denominator. And why can't it be 4? Because even though I've eliminated x plus 4, in the original expression, on the second expression, x squared plus 3x minus 4, right here there's an x plus 4. And negative 4 would bring us 0 in the denominator. Now, I got an expression here, x squared plus 12x plus 36 over negative x cubed minus 8. And I'm saying which line is the asymptote, A, B, or C? And really, it's going to be A. I'm sorry, C, right here. No, I said A, C. And that is at 2. Because 2, if x is 2, 2 cubed equals 8. And 8 minus 8 here, there's a negative on the outside. We got to do everything on the inside first. 8 minus 8 is going to equal 0. And I have a 0 in the denominator. We cannot have, or what the expression in the numerator cannot have 0 parts in the denominator. Finally, I look at this one right here. And I've graphed this 3x squared plus 8 over x squared minus 64. Well, that's the difference of squares right there. That'd be x plus 8, x minus 8. X plus 8 times x minus 8. So when I look at this, my x's cannot be 8 or negative 8. And you can see this is where my asymptote is right here. Right here at this point. There's two asymptotes, negative 8 and 8. So it'd be answers A and answer C.